Lab 3 Blackhole Orbit Submission. Objective 1. Estimate a black hole mass by using Newton's second law of universal gravitation, the results of given data, and analysis of given data. 2. Discuss my assumptions about the lab's elaboration. 3. Make a computational model about the star's movement orbiting around the black hole. 4. Answer questions. Well, we were given a star data file from one time, giving our xy position from a star. I got my star mass, that in my case was 4.2053 E27 kilograms, and that's my mass 1. My time step, or delta t, is 86,400 seconds, that is 1 Earth day. My black hole position minus 2 E10 in x, and in y minus 3 E10 and 0 in z meters. My black hole mass, that is what I need to find. I got my constant g, 6.67 E minus 11, and the gravitational formula is given in the next way. F net is equal constant g times mass 1 times m mass 2 over distance squared. If we clear to mass 2, we got F net times distance squared over constant g times m1. Distance between a star and a black hole, and that will be our r. R is the distance between the centers of the masses. Also, Pythagorean theorem works fine. The equation also is given in the distance is equal r2 minus r1. Fnet formula. Fnet is equal to change in momentum over delta t when delta t is really small, and that's the momentum principle. From that, I compute my model in Python. I got my star mass 4.2053 E27, my delta t 86,400, to read my CSV file that I downloaded, also calculating the velocity from data, and compute the x and y component of velocity. From that, I got my index 1, and in here in the main loop, in the calculation loop, I got my initial and final velocity, initial and final momentum, delta b and delta p. Recalling that momentum is the product between mass and velocity. As I said in my data, Fnet is equal delta p divided by delta t, and that's equal to dp dt. I compute also the Fnet parallel and my Fnet perpendicular. Instead of making it separate, spread my black hole mass formula, I did it in Python, applying the g 6.67 e minus 11, the distance, I used the Pythagorean theorem, the black hole mass, that is Fnet magnitude times distance squared divided by constant g times star mass, as I said in my formula. From that, I got also my arrow scale, that in my case was 9 e minus 11. Also, I got the array 1000, and I wrote to print the black hole mass. I run it, and as you can see, it makes the star's movement around supposedly the black hole that is in the middle. My red arrow is the Fnet parallel, my cyan arrow is the Fnet perpendicular, my dark blue arrow is my Fnet. And as you can see in my Python shell, as I told you, I wrote to print the black hole mass, and I got 5.182 E31, and I can check it right in Web-Assign, and that was the correct answer in my case. Now we need to answer some questions. Question number 1. What does it mean? In your analysis, you should discuss how Fnet are different from delta momentum divided by delta time. Well, Fnet affects the star motion, the forces in the system. Well, the change in P over delta T tell you or describe how the star moves while time passes, even though both of them are the same in magnitude, but in definition they are not the same, as I explained you right now. My question 2. What if, imagine the black hole whose mass you found was removed and a different black hole mass was placed in the same location? Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the black hole. Could you tell the difference? Well, there's no difference. Why? There is very clear. In the instructions said, assume the motion of the observed star remains unchanged. That means that there's no change. Well, in that case, my data will be the same, and as the constant g is just 1, there will be no change in the m2 about the new black hole. Thank you.